Yeah. తీసుకో. So good evening. So right. So last day we discussed the time domain specifications and we started steady state errors also. In steady state errors, we make a small conclusion. What is that conclusion? Whenever type equal to input, then the error is constant. ESS is constant. Type greater than input, steady state error is 0. Type less than input, steady state error is infinity. So based on the type, we can decide the steady state error. So based on this, I make a conclusion that steady state error required to calculate only 3 cases, that is type 0 and 0 input, that is called step. Type 1, what I told, 1 input is ramp. Assign the value to the input. Step is 0, t power 0, na, that's why 0. T power 1 na ramp. Next type 2. And the second input is parabolic. Remain all the cases, the error may be 0 or infinity. And another conclusion, what is error here? Steady state error, A by 1 plus K. Here what is the steady state error? A by K. Here what is the steady state error? A by K. What is A? A is called amplitude of input. A is called amplitude of input. K is called system gain. K is called system gain, or simply K is K equal to numerator constant by denominator constant. K equal to numerator constant NR means numerator. Numerator constant by denominator constant. Denominator constant. Numerator constant by denominator constant, where not in closed loop transfer function in G of S, H of S equal to 1. You have to calculate in G of S when H of S equal to 1. H of S must be equal to 1. You have to calculate in G of S when H of S equal to 1. H of S equal to 1. Okay, up to this. Okay, up to this we completed. Up to this we completed. Next, come on. Now note another problem. First problem, write it. Find the steady state error. Find the steady state error to the given unity feedback system. To the given unity feedback system. Unity feedback system. Find the steady state error to the given unity feedback system. G of S equal to 10 into S plus 1 by S square into S plus 2 into S plus 4. So find the steady state error to the given unity feedback system for the following input. For the following input. Following input. R of t equal to 10 plus 5t plus t square by 2. 1t square by 2. Come on, do it. First method will go by standard procedure. First I'll solve by standard method. Next we'll go by shortcut. First I'll solve by standard method. So that is method 1. Method 1. ESS equal to limit S tends to 0, S into R of S by 1 plus G of S. ESS equal to limit S tends to 0, S into R of S by 1 plus G of S. 1 plus G of S. So that equal to, now find the R of S, G of S we know. Find R of S, substitute and find the steady state error. So find R of S. What is R of S? Tell. 10 by S plus apply Laplace. 5 by S square plus 1 by S cube. 1 by S cube. So that equal to R of S equal to. Bolo. Now LCM you take. You take LCM. S cube. LCM what? 10 S square plus 5S plus 1 by S cube. 10S square plus 5S plus 1 by S cube. Now substitute here R of S and G of S. Substitute R of S and G of S. So now one more thing, ESS equal to limit S tends to 0, S into what is R of S? 10 S square plus 5S plus 1 by S cube divided by 1 plus G of S. What is G of S? 10 into S plus 1. 10 into S plus 1 divided by S square into S plus 2, S plus 4, S plus 2 into S plus 4. So now simplify this, you will get the answer. Now simplify this, we'll get the answer. So what happened now? Come on. So simplify. What will get the answer? 1s is get the cancel. Then s square is left. S square is left. Then what I can write? Limit s tends to 0. 10s square plus 5s plus 1 divided by s square left. S square comes in the denominator. S square into s square comes denominator. Here also square into 10 into s plus 1 by s square into s plus 2 into s plus 4. S plus 4. Now square cancelled. Square cancelled. And put it here, s tends to 0. S tends to 0. Now what is the answer? Tell. S tends to 0. Now what is the answer? ESS equal to, bolo, limit s tends to 0. What is left in the numerator? S 10s square 5s plus 1 divided by denominator. What is left here? 0. 0 plus 10 into s plus 1 divided by what is there here? S square cancel na. S plus 2 into s plus 4. Now substitute s tends to 0. If substitute s tends to 0, this is 0, this is 0, this is 0, this is 0. What is left in the numerator? 1 by 0 plus 10 by s plus 4 only given. Yes, correct. 10 by, bolo, 8, 2 into 4. 10 by 2 into 4. 2 into 4. That means 8 by 10. That means you are getting 0.8. The steady state error. The steady state error is 0.8. This is by the standard procedure. But it is very lengthy, na? It is very lengthy, yes or no? 0.8 is the answer. Very good. So now, this is the standard procedure. But it is the lengthy. So how to write directly? How to write directly? Listen. How to write directly? Listen, bhaiya, listen. How to write directly means just compare type and input. Compare type and input. So first g of s, what is given? G of s given in 10 into s plus 1 by s square into s plus 2, s plus 4 is given. And h of s 1 unity feedback mentioned. And r of t given what? 10 plus 5t plus 1t square by 2 into u of t. So now tell. Now come on. Now compare type and input. Automatically you'll get the answer. Compare type and input. So what is the type here? Type 2. This is a type 2 system. Type 2 system. S square na. S square type 2 system. Compare type and input. Here how many inputs are there? One is t power 0. That means step, t power 1 ramp, t power 2 parabolic. That means it is a combination of 3 inputs. Step, ramp and parabolics. It is a combination of 3 inputs. Combination of 3 inputs. Now come on. Now get the answer. So one side type, write it type. Next input. Next steady state error. So what is the type? 2. 2. Type is 2. Next inputs. First 0. Next 1. Next 2. Inputs is 0, 1, 2. 0, 1, 2 inputs. Next type greater than 0. Type is greater. Type greater means steady state error is 0. Type greater than 0. Type is greater than 0, 0. Next, type 2. Type is fixed. Type is fixed. Input only 3, 0, 1, 2. Type greater 0. Second also type greater. So 0, 0 plus 0. Third is type equal to input. Type equal to input means what is the steady state error plus what is the steady state error? A by K. A by K. What is A? Amplitude of the input. Which input? 2 input. 2 input means parabolic. What is amplitude? 1. A t square by 2. A parabolic input. Parabolic input is a t square by 2. So this is the standard form. A is 1. K is called numerator constants by denominator constants. What is the numerator constant? 10 into 1. 10 into 1 divided by what is the denominator constant? 2 into 4. Denominator constant is 2 into 4. That means 8 by 10. That means 8 by 10. That equal to 0.8. That equal to 0.8. So answer is 0.8. A by K. A is amplitude of the input 1. K is called simply K means what? Numerator constant how much? 10 into 1. What are the denominator constant? 2 into 4. So that means 10 by 8. So I written 10 by 8. 10 by 8. So if it goes to numerator 8 by 10. Answer is 0.8. Answer is 0.8. So like this. So we can get the steady state error. Like this we can get the steady state error. So no need to go by procedure. Now even no need to write like this also. Directly we can write the steady state error. How to write means, for example, what is R of t? Tell 10 t square plus, sorry. What is R of t? Tell 10 plus 5t plus 1 t square by 2. 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 Now tell R of t. 10 5t 1 t square by 2. Now steady state error if you find. So first type is 2. Type 2. Observe the t powers and s power. So t power type 2. Here type 2 input is 0. Type is greater 0 plus. Type 2 input is 1. Type is greater 0 plus. Type 2 input is 2 constant. Type 2 s power 2 t power 2. A by K. A is 1. K is called numerator constant 10 into 1. By denominator constant 2 into 4. 2 into 4. Then solve this, you will get the answer. Then solve this. What is the answer? Tell 0 plus this value. So 8 by 10. So that means 0.8. 0.8. So this is the answer. So 0 plus 0.8 equal to 0.8 only. So this is the answer. Like this, we can get the steady state errors directly. Okay, K is called KA, KP, everything is K only. Okay. Right. Type 2 you can find KA, then A by KA. KA is called K only. Even if you find K, that constant only will get, that's all. Right. Next problem. Next problem. Okay, completed na? Next problem. Right. Find the steady state error. Find the steady state error, ESS, to the given unity feedback system. To the given unity feedback system. To the given unity feedback system. Find the steady state error to the given unity feedback system to the following inputs. To the following inputs. To the following inputs. To the following inputs. So G of S equal to system is 10 by S into S plus 2 you take, no problem. So what is mentioned? Unity feedback mentioned h of s1. First bit 10 u of t. Second bit 10 t u of t. Third bit 10 t square u of t. 10 t square u of t. Fourth bit 1 plus t u of t. 1 plus t u of t. Fifth bit 1 plus t square into u of t. Come on, do it. For all these 5 problems, tell the steady state error. Come on, Guruji. Come on, come on. Come on, Guruji. First 0. So what is the answers? Come on. Completed. Zero, 2, infinity, 1/5, infinity, 0.2. Okay, I'll write the answer. Listen. So just what is the type of the given system? Type of the given system is type is 1. That means only ramp input you will get the constant. Remain all are either zeros or infinity. Type is 1 means you will get the constant steady state error for only ramp input. Remain all are zeros or infinity. Now come on, calculate ESS. So now type here t power 0, na, this is t power 0. Type is greater. Type greater means error is 0. Next type input constant. Here 1, here also 1. So A by K. A is 10. K is 10 by 2. That means answer is 2. On 10, 10 cancel, answer is 2. Next, here type is less. Type is what happened? 1. Input is 2. Type less means steady state error is what? Infinity. Next, fourth one. First one type is 1. Here type 0. So 0 plus. Type 1. Here input 0. So type is greater. So 0. 0 plus. Next, type 1 input also 1. Type 1 input 1. A by K. A is 1. K is 10 by 2. 10 by 2. That means 0.2. 0.2. Next, last one, 0 plus. Already we find for the t, 0.2. Next, last one, what? Type is less. Type is less than infinity. Less than input. So infinity. So answer is infinity. So 0 to infinity, 0.2 infinity. Okay? I hope got it. Next, one more problem. Okay? Next problem. Repeat the above problem. Repeat the above problem. So I'll take g of s equal to, for example, 1 by s plus 5 into s plus 10. H of s1. And same inputs I'll take. 10 u of t, 10 t u of t, 10 t square u of t, 1 plus t u of t, 1 plus t square. Come on, do it. Abdul, what is the doubt?
సార్ ఇందాక ప్రాబ్లం లో అది మనం టైప్ అని ఎలా తీసుకుంటాం సార్?
Here, what is the type? 10 by s into s plus 1 means what is the type?
s plus 2 కదా సార్, అంటే స్క్వేర్
Type
వేరియబుల్.
and what is the definition of type? First you tell.
నేను లేను సార్ అది ఆ టైం.
In the first class I discussed in the first class type and order. First second classes it came. It is number of poles at origin. How many poles at origin?
ఆరిజిన్ ఒకటే.
That's all. That is type 1.
ఓకే, అంటే s minus 2 అంటే -2 అంటే అది పోల్ కదా సార్?
That is not the in order. Both you have to consider. You read the basics. That's why you should not miss the class. If you miss the class, then problem.
Yes,
Read
sir.
the starting classes. Type means poles at origin. Order means total number of poles in the S plane. Okay.
ఇప్పుడు మనం టైప్ 1 అంటే ఇప్పుడు s -2 తీసుకుంటామా, s = 0 తీసుకుంటామా సార్? అదే
Pole at origin. Type represents the pole at origin.
పోల్ అట్ ఆరిజిన్.
How many poles at origin is there?
1 పోల్ -2.
-2 is a pole at origin.
No, s = 0.
Well, that's all. One pole. If I put s square, type 2. If I put n, s power n, type n.
Okay, sir.
Basics you should be strong. So listen class every day carefully. Very good. Right. Next answer say right. Here type 0 system. It is the type 0. No pole at origin. Type 0 system. Come on, find the steady state errors. Type 0. Type 0 means what happened? You will get for only first input, step input. So what is the steady state error for step input? A by 1 plus k. A by 1 plus k. For step, what is the steady state error? A by 1 plus k. What is A? 10. Given is 10. So 10 by 1 plus k. K is called numerator constant 1. Denominator constant 50. So what is the answer? So 500, I think. 500 by 51. I think 9.8, I think. 9.8, na? 9.8, correct. 9.8, I think. Next, type is what? Lesser than input. Infinity, 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 infinity. Type is lesser than input, then it will become infinity. Next question. Completed, na? Next question. Repeat the above problem. G of s equal to s plus 1 by s square into s plus 5 into s plus 10. H of s1. First bit, come on, do it. 10 u of t. Second input. These are inputs. These are inputs. Second input, 10 t u of t. Third input, 10 t square u of t. Fourth input, 1 plus t square into u of t. Fifth input, 1 plus t you take here. 1 plus t into u of t. One plus t square into u of t. Come on, tell the answers. Zero, 500, 50. Shreya. Come on. Any more answers? Zero, 550. Right. Some students. Listen here. 550 is wrong answer. See, listen, whenever they given parabolic input, you should be careful. Either it is in the standard form or not, we should observe very carefully. For example, here, what is the type here? Type of the system is 2. S square means type is 2. Type is 2. S square, na, type is 2. Okay. Now, come on. Steady state errors you find. Steady state error. Here, t power 0. Type is 2. Type is greater. Type greater means 0. Here, t power 1. Here, 2. Type is greater, 0. But when you come to the third one, type is 2, input also 2. But what is the parabolic input standard form? Parabolic input standard form is what? A t square by 2. A t square by 2. It should be in the form of a t square by 2. So is it there in the standard form? No. So a t square by 2 into u of t. So you have to adjust into standard form. 10t square is there, but by 2 should be there. By 2 into 2. By 2 into 2. This will become the standard form. Now write the steady state error. A by k. A is what? 20. A is 20. K is what? Numerator constant 1. Denominator constant 50. So the answer is 1000. The answer is 1000. Next, fourth one, tell 0. Fourth one, type is greater. Fifth one, you tell 0 plus type here, type 2, input 2, but not in standard form. Divided by 2, multiply by 2. So 2 by 1 by 50. That means what you are getting? 100. So this is the answer. So 0, 1000, 0 and 100 is the correct answer. Some students written correct answers. Very good. Okay. So be careful whenever they give the parabolic input. So always parabolic input should be adjusted into the standard form. And another thing, be careful when you give the what? Type 0 system. Because don't take A by K. For step input, you have to take A by 1 plus K you have to take. For step input, A by 1 plus K you have to take. Okay, na? Next, one more problem. One more problem. Repeat above problem. G of S equal to 1 by S square into S plus 5 into S plus 2. H of S bar. First input 10 U of T inputs. Second input 10 T U of T. 10 t square of t. Come on, tell the answers. Come on, tell the answers. Same as previous sum. All are infinity. Same. Is it same? Hmm? Okay, listen here. I told one statement before the steady state error, starting of steady state errors. I given one statement. What is that? Steady state errors are valid for only closed loop stable systems, I told. Steady state errors are calculated only for closed loop stable systems. Closed loop stable systems. Steady state errors are calculated to only closed loop stable systems. Check it, is it stable or not? So if I write, this is a closed loop system, H of S1 means feedback is there. Feedback means closed loop. You have to check the closed loop stability. What is the closed loop transfer function tell? G by 1 plus G. Now write the transfer function, closed loop transfer function. What is the closed loop transfer function? 1 by, come on, denominator expand it, S power 4 plus 15 S cube plus 50 S square. 50 S square. Then again, this is expansion of this. Then numerator term added, numerator term added means plus 1. Then this denominator is called characteristic equation. This denominator is called characteristic equation. S power 4 plus 15S square plus 50S plus 1. Make equal to 0, then it is called characteristic equation, 1 plus G of 0. So in the characteristic equation, there is a missing term here. So in the RH criteria, it will come next topic, RH criteria only. So in RH criteria, there is a necessary condition. What is the necessary condition? The characteristic equation should consist all the coefficients, and all the coefficients should have the same sign. All the coefficients should have the same sign. If any missing coefficient is there, blindly we can say that it is a not stable system. Not stable means it may be marginal stable, it may be unstable. It may be marginal stable, it may be unstable. Here what happened? S power 1 coefficient missing. S power 1 coefficient missing. S power 1 coefficient missing. S power 1 is missing. So that means what? It is not stable. Not stable. Not stable means it may be it may be marginal stable, it may be unstable. I already checked it is unstable system, no doubt. I already verified it is a closed loop system is unstable with RH criteria. We can check it. 2 poles in the right is there here. So the unstable system, the given system is, given closed loop system is unstable. 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 US means unstable. And steady state error for any input, ESS for any input is infinity. And ESS for any input is unbounded. We can say ESS is unbounded. SS is unbounded. Unbounded. It is unbounded. Unbounded. It may be plus infinity, it may be minus infinity. Okay. So how to check that plus or minus infinity means you have to find the C of t, you have to substitute t tends to infinity, which is not possible. So simply write it is unbounded because here fourth order system, na roots finding it is difficult. Okay. So simply unbounded, steady state error is unbounded. Okay, na, or plus or minus infinity. Okay. So like this, you have to write the answer. So that means what is the conclusion? What is the conclusion? Right. Right. From this type. Right. Next. So the given system is unstable. The given system is unstable. So that's why before solving any question, first verify the type. Before finding steady state error, verify the closure. Check the options first. Before finding steady state error, check the options. Check the options. Okay, you should verify the options. If any one of the option is, if any one of the option is, option is none, in case none, or infinity, or unstable is given, then check the closed loop stability. Compulsory you have to check by using RH criteria. So be careful whenever they give the question on type and R, whenever they give the question on steady state error, whenever they give the question, it is very easy. If you observe the time domain analysis, 30% of the questions you'll find on steady state errors in GATE and IES. There are many questions you'll find. Mainly two topics important in the time domain analysis. One is time domain specifications. The second one is steady state errors only. Steady state errors are very, very easy, but the many students, they'll do the mistake. So before solving any question related to steady state error, you check the options. If all the options are constants like 5, 10, 20, 50, without any second thought about the stability, directly you find the steady state error. If infinity is there, here infinity is there, for example, none is there, then compulsory check the closed loop stability. The system may be unstable. Be careful before solving the questions on steady state errors. ठीक है ना? In case fill in the blank, if it gives na, in case filling the blank given, so then you directly calculate the steady state error, because in the fill in the blank you cannot enter the infinity, you cannot enter the none, so you have to enter the only value. So the compulsory fill in the blank question given means compulsory will give the stable system only. ठीक है ना? So next. Okay, next problem. Come on. For the system shown in figure, for the system shown in figure, the steady state output is the steady state output is 2 to the unit step input. And the time constant is 0.4 seconds. Then values of K1 and K2 are find the values of K1 and K2 are. Come on, solve it. Solve it. Come on, what is the answers? So read the question carefully. Steady state output is different. Steady state error is different. Steady state output is different. Steady state error is different. What are the K1, K2 values? Anybody? Come on, Guruji, come on. Anybody? Answer 0.5, 5.5. Very good, very good. Okay, we'll solve it. Listen. First study, see, whenever they give any question in the exam, simply be remember, try to use the given data, automatically you'll get the answer. Just use the given data, automatically you'll get the answer. Just use the given data. Automatically you'll get the answer. Use the given data, that's all. What is the given data tell? Come on. Steady state output given. Steady state output means CSS. Steady state output. Steady state output. Steady state output. That is called CSS. So how much given? 2. For which input? Unit step input. Unit step input. Unit step input. Unit step input. And time constant given. What is the time constant? Tell 0.4 seconds given. Time constant 0.4 seconds given. So now find CSS. What is the formula for CS? CSS means the output at t tends to infinity. That is limit t tends to infinity into C of t. So the output at t tends to infinity is called steady state output. The output at t tends to infinity called steady state output. That equal to what? Limit s tends to 0, s into C of s. S into C of s. Limit s tends to 0, s into C of s. C of s. So now find C of s. From this, you find C of s by R of s. From the given system, find C of S by R of S. What is C of S by R of S? Find closed loop transfer function. Find closed loop transfer function. Then substitute here C of S. So what is the closed loop transfer function? C of S by R of S equal to, what is the answer? K1 by S. Opposite sign of the feedback plus numerator term K1. Product with feedback gain K2. Product with feedback gain K2. So that this is the closed loop transfer function. That means what is CS tell? CS equal to K1 by S plus K1 K2. K1 K2 into R of S. Now substitute this C of S in the CSS. Substitute it. So now tell CSS equal to limit S tends to 0, S into C of S. What is C of S? K1 by S into K1 by S plus, wrong, correct only. K1. Okay, now come on, K1 by S plus K1 K2. K1 K2 into R of S. What is R of S tell? Unit step input mentioned. That means 1 by S. Then SS cancelled. Then S tends to 0. What is the answer tell? What is the answer? K1 by K1 K2. K1 by K1 K2. So that equal to how much mentioned? K1 K1 cancel. What is CSS given? 2. 2 equal to what? 1 by K2. So that means what is K2 you are getting? K2 equal to 0.5. 1 by 2 is a 0.5. That's all. Next, they given what? Time constant. Use the time constant, get the second factor. So time constant. What is the pole location here? What is the transfer function you got? Tell C of S by R of S equal to C of S by R of S equal to what? Tell K1 by S plus K1 K2. So K1 by S plus K1 K2. Now locate the poles in the S plane. You locate the poles in the S plane. What is the pole location? Tell minus K1 K2. Pole location is minus K1 K2. What is the time constant tell here? Minus 1 by real part of the pole. Minus 1 by what is the real part of pole? Minus K1 K2. Minus plus. Equal to how much? They given 0.4. And what is K1 tell? What is K2 tell? 0.5. So substitute K2 0.5. 1 by K1 0.5 equal to 0.4. Then find the K1 value. So K1 equal to how much? You will get, I think, 5. K1 equal to 5. So like this, you have to find the what? K1 and K2. Just to use the given data. Any question, try to use the given data, automatically will get the answer. Okay, na? I hope you got it, all of you. Next problem. Next problem. For the system shown in figure, for the system shown in figure, the undamped frequency of oscillations are the undamped frequency of oscillations are 4 radians per second, and the damping ratio is 0.7. The values of K and A are draw this diagram. Come on, do it. Find the K and A values. Find K and A. 16.22. Right, very good. K16. A is 0.225. Correct, very good. Okay, listen. First find closed loop transfer function. First find closed loop transfer function. First find closed loop transfer function. Closed loop transfer function that equal to K by S into S plus 2. Opposite sign of the feedback plus numerator K into 1 plus AS. 1 plus AS. So K by S square plus S. So 2 plus Ka plus K is the transfer function. Now compare with standard form. You compare with standard form. So you compare with standard form. Okay. You compare with standard form. So what you are getting, tell? What is the closed loop transfer function you got? K by S square plus S2 plus Ka. I think plus K. Compare with the standard form, that is omega n square by second order system. No, it is. So you should observe the order of the system. So it is a second order system. So omega n square by S square plus 2 zeta omega ns plus omega n square. Compare with this common. So K equal to what? Omega n square. Omega n given 4. So 4 square. That means 16. Next, 2 zeta omega n equal to what? Tell 2 plus Ka. 2 plus Ka. 2 plus Ka. 2 into zeta. Zeta how much given? 0.7. Omega n how much given? 4. Equal to 2 plus Ka. K is what? 16. A. Find A value. So if you solve for A, you will get 0.225. A is 0.225. That's all. Next problem. One more problem. One more problem. Try to solve all the problems in volume 1 today. Volume 1, volume 2, previous gate questions. Most of the people not solving any previous questions. That is the problem. Right. The system and its unit step response is shown in figure. The system and its unit step response. The system and its unit step response is shown in figure. Find the system gain. Find the system gain. Find the system gain. Draw this. That is K. You have to find K. K by S tau plus 1. Right. Come on, do it. Tell the answer. Point 8. 0.8. Why you are telling 0.8? I think you are taking this is AK. And K is A is 1 point. What is K here? Which system it is? Open loop system or closed loop system? Is it open loop response or closed loop response? It is a closed loop response, na? So you have to find closed loop K. You find closed loop transfer function, find the K. How to find the K? Numerator constant by denominator constant. This is not AK. So what is the closed loop transfer function? Method 1, for example, method 1. What is the closed loop transfer function? C of S by R of S equal to K by S tau plus 1 plus K na. K by S tau plus 1. Numerator term added na K na. Now tell what is K? What is K? Here K by 1 plus K. This is what? A into K. K is nothing but gain. Gain of the system. What is the gain? K by 1 plus K equal to how much? 0.8. 0.8. Then A is 1. A1 mentioned unit step. That means K by 1 plus K equal to 0.8. That means K equal to 0.8 plus 0.8 K. Then solve it, you will get the answer. What is the answer? 0.8 K. If you come this side, 0.2 K. 0.2 K equal to 0.8. K equal to how much? 4. It is not a open loop gain. It is not a open loop system response. It is a closed loop system response. You have to find the K for closed loop system. K equal to 4. Or method 2, we can solve by other method also. Here, what is the steady state error? What is the steady state error? 0.2 na. Error is 0.2 na. So now go for method 2. Method 2, use the steady state error and get the answer. So method 2. Method 2. Steady state error is 0.2. For which input? Tell. Unit step. Unit step input. What is the answer? Tell. 0.2 equal to what is the steady state error? A by 1 plus K. A by 1 plus K. Now here what is K? K is a numerator constant by denominator constant. Numerator constant by denominator constant. Where in G of S, I told very clearly. In G of S, when H of S equal to 1. And now tell 0.2. What is G of S here? K by S tau plus 1. K by S tau plus 1. H of S 1. So 0.2 equal to what is a unit step input? 1 by 1 plus K. K means numerator constant by denominator constant means K only. Now 0.2 plus 0.2K equal to 1. That means 0.2K equal to 0.8. K equal to 4. K equal to 4. That's all. So like this, you have to get the answer. I hope you got it. Right, next. Next problem. Next. Put the heading steady state errors to the disturbance input. Steady state errors to the disturbance or noise inputs. Steady state errors to the disturbance input. Disturbance or noise. Okay, na? Now listen. So I'll consider one particular case. I'll discuss R of S plus summing point ten by S plus 2 D of S phi by S plus 4 minus. Okay, first I'll explain the concept, I think. Listen here. I'll take here G of S first. I'll explain the concept. After that, we'll take the numerical. So how to find the steady state errors for disturbance, noise, multi-inputs, like sometimes they'll put 3-4 inputs. They'll ask the steady state errors. How to find the steady state error for multi-inputs? How to find? Listen here, all of you listen. First of all, where the error calculated, anybody? With R of S or with D of S? Error is calculated with R of S or with D of S? Anybody? Error is calculated with R of S or D of S? R of S. R of S. Very good. Error always calculated with R of S only. They may give multiple inputs. Because R of S is called reference input, which is called required input. R of S is a reference input, which is a required input. R of S is a reference input, which is required input. That's why always error calculated with only R of S. Here it is E of S. It is E of S. Now come on. Find the error. Find E of S by R of S. Come on. Find first I'll calculate for E of S, R of S, next calculate for D of S. So steady state error with R of S I'll calculate. Steady state error with R of S. With R of S. Find E of S by R of S. Find E of S by R of S. E of S by R of S. Come on, tell. E of S by R of S, you tell. Here E of S. Here R of S. What is E of S by R of S? What is the forward path gain, tell? What is the forward path gain? R of S to E of S 1. Here to here forward path gain 1. D of S 0. Each time you have to consider only one input. D of S 0. So 1, this loop is touching, divided by loop gain. One opposite sign of loop gain. Na? So that means what I will get? 1 divided by 1 plus G1, G2. 1 plus G1, G2. Yes or no? One opposite sign. One opposite. What is the loop gain tell? G1, G2 minus. Opposite term means plus G1, G2. So numerator term 1. Year to year path gain 1. So 1 by opposite sign of loop gain. So 1 plus G1, G2. So that is not C of S by R of S I am writing. E of S by R of S. Dekho here. E of S by R of S. Now find E of S. What is E of S tell? R of S by 1 plus G1, G2. Next find steady state errors. Limit S tends to 0. S into E of S. Limit S tends to 0. S into E of S. Now ESS you find. What is ESS? Limit S tends to 0. S into what is E of S? R of S by 1 plus G1, G2. So this is the steady state error due to R of S. This is the steady state error due to R of S. Now find steady state error due to D of S. Next find with D of S. Steady state error with or due to steady state error due to steady state error due to R of S. Here steady state error due to D of S. Due to D of S. Come on, solve it. Find steady state error due to D of S. Find E of S by D of S. Find E of S by D of S. Come on. Solve it all of you. Find E of S by D of S. D of S disturbance or it may be noise. Sometimes in the exam they'll mention noise. Sometimes they'll write the disturbance. What is the disturbance? It is occurs in the system. What is the noise? It is the external signal enter into the system. Disturbances, noise, or unwanted signals. That's all. Unwanted things. So find it. So input is D of S. Output is E of S. Output is E of S. We want E of S by D of S na. We want E of S by D of S. What is the forward path gain tell? D of S to E of S. What is the forward path gain? G2 into minus 1. Dekho. Here 1, G2 into here minus 1. So that means what you are getting? G2 into minus 1. G2 into minus 1. So that means minus G2. So minus G2 by 1 opposite sign of opposite sign of loop gain na? What is the loop gain tell? 1 plus G1 G2 opposite sign. So plus so G1 G2. Only one loop na? So opposite sign of means only one loop. Automatically you'll get plus G1 G2. Now E of S. Come on. E of S equal to what? Minus G2 D of S by 1 plus G1 G2. So now what is the steady state error formula? ESS equal to limit S tends to 0, S into E of S. So then ESS equal to limit S tends to 0, S into what is E of S tell? Minus G2 D of S by 1 plus G1, G2. 1 plus G1, G2. 1 plus G1, G2. Now, this is the steady state error due to disturbance. Either you remembered or not, in chapter 1, one question is there, steady state error due to disturbance. How can you reduce? In volume 1, I think, in volume 1, one same thing is there. I think in volume 1 only, one question is there. I'll tell in time domain analysis. Volume 1 or volume 2? I think volume 2. In volume 2, question number volume 2, question number 12. Check it once. Volume 2, question number 12. You check it. Same thing. What is the question for the given system? How can the steady state error produced by the step disturbance can be reduced? How can you reduce? How can you reduce the steady state error of the disturbance? Simply by increasing G1. If you increase the G2, gain of the G2 increase, what happened? Numerator increasing, denominator increasing. If I increase the G1, what happened? What happened? Error is decreases. So by increasing the gain of the G1, by increasing the DC gain, K is called DC gain or steady state gain, whatever it is. So by increasing the K value, so by increasing the gain of the G1, by increasing the gain of the G1, by increasing gain of G1, gain of G1. So what happened? By increasing gain of G1, so we can decrease the steady state error. We can decrease the steady state error. Okay, na? Next, total steady state error is, both you have to add. So limit s tends to 0, s into denominator term same na, both denominator sum same. So 1 plus G1, G2, denominator same. So numerators are added. So numerator what here? R of s minus G2 into what? D of s. That's all. This is the total steady state error. Both are added. Just add it both. You will get this is the answer. Okay, na? I hope you got it. One problem now we'll solve. But don't think that, listen, this is path gain. Year to year, what is the path gain? Output is E na, E of S by D of S. Some people, they'll sleep, I think. I explained clearly, start at D of S, G2 into minus 1 minus G2. Again, why G minus G2? So listen. Put the phone aside. Listen, be concentrated. Na? Right. So now, this is the total steady state error. Path gain, what is the output? E of S. What is the input? D of S. What is the output? E of S. What is the input? R of S. Check the path gain. That's all. Automatically, you will get the answer. Na? Venkatesh, what is the doubt? Venkatesh,
Sir,
tell.
sir, there in loop 1 plus G1 G2 or 1 minus G1 G2, sir.
Why
Sir,
minus
have,
tell? This minus sign will come here na. One opposite sign. Okay, I'll take opposite sign. Means here minus. Now tell.
okay, sir.
One
Okay,
what
sir.
is the loop gain? Tell. G2 into minus 1 into G1 and minus G1 G2. What is the answer?
Yes.
Same or different?
Same, sir.
Block diagram, signal flow graphs. This should be perfect, man. Okay, next. Right. Complete, and this is total steady state error. Next, note down one problem. Note down one problem. Find the steady state error. Okay, note down one problem. Find the steady state error. Find the steady state error to unit step input and step disturbance. To unit step input and unit step disturbance. To the given system. R of S. Ten by S plus 2. D of S. Phi by S plus. Come on, Guruji, come on, solve it. Error is always with R of S only. Error with always R of S only. Come on, tell the answers. Get the solution. Completed anybody? Five by 58 by 58. Minus 1 by 29. Correct. Very good. Listen. First find with R of S. So steady state error with R of S. ESS due to R of S. E of S by R of S. What is the path gain? 1 by path gain is 1. So 1 divided by what is the loop gain? Tell. 1 opposite sign of loop gain plus 50 by 10 into 5. 50 by S plus 2 into S plus 4. S plus 2 into S plus 4. Now find E of S. S plus 2 into S plus 4 divided by S plus 2 into S plus 4 plus 50 divided by R of S. So now write E of S. So what is E of S? S plus 2 into S plus 4 into R of S divided by S square plus 6s plus 58. Now find ESS. So limit s tends to 0. S into E of s. So s plus 2, s plus 4 divided by s square plus 6s plus 58 into R of s is 1 by s. SS cancelled. S tends to 0 is substitute. Then what is the answer? 8 by 58. 8 by 58. 8 by 58. Is it correct? Next, find due to R of s, ESS. Due to D of s you find. So E of s by D of s equal to, what is the path gain year to year? Minus 5 by s plus 4 is the path gain. Year to year, check out 5 by s plus 4 into minus 1. Minus divided by loop gain. 1 plus 50 by s plus 2, s plus 4. Then if you simplify this, what I will get? S plus 4 cancel. So minus 5 into s plus 2 numerator divided by s square plus 6s plus 58 denominator. So this is E of s. Consider E of s. D of s is other side you take. This is E of s. Product here. Now find steady state error. Limit s tends to 0, s into E of s. Minus 5 into s plus 2 by s square plus 6s plus 58 into 1 by s. Step disturbance, ss cancel. 0, 0. So how much you are getting? Minus 10 by 58. Minus 10 by 58. Then total you find, total ESS. Both add it. Total ESS means both you should be added. That means 8 by 58 minus 10 by 58. That is minus 2 by 58. Minus 1 by 20. That's all. This is the answer. I think correct. Correct. Very good. Next, put the heading steady state errors to the non-unity feedback system. Next, steady state errors to the non-unity feedback system. Steady state errors to the non-unity feedback system. Non-unity feedback system. Again, say steady state errors are calculated to only unity feedback systems. Steady state errors are calculated to only unity feedback system. If non-unity feedback system is given, then it should be converted into unity feedback. it should be converted into unity feedback. Unity feedback as follows. So for example, I'll draw the diagram. R of S plus G of S, C of S, H of S. So this is the non-unity feedback system. Unity or non-unity? It is a non-unity feedback system. It is a non-unity feedback system. Now convert into unity feedback. How to convert into unity feedback? First of all, why we don't get error for non-unity? If I write error here, what is the error you are getting? E of S in case I'll write. What is the answer? R of S. This is R of S. This is minus C of S into H of S. C of S. This is C of S, na? C of S into H of S. Minus C of S. Is it error? What is the definition of error? R of S minus C of S only, na? Not C of S into H of S. R of S minus C of S only. But we are getting C of S, H of S. That means H of S you have to make it 1. H of S you have to make it 1. Then only we can get the error. So that means you have to make it unity feedback. How to make it unity feedback means, so listen, I will add one positive feedback, one negative feedback. Just I will add one positive feedback, one negative feedback. One positive feedback. Listen by all of you, listen. One positive feedback. This is plus. And one negative feedback. One negative feedback. One positive and one negative feedback. So that's all. Now what you have to do, you simplify all the blocks. You simplify all these blocks. You simplify all these blocks. If you simplify all these blocks, then what is left? Unity negative. And one more thing here, whatever the modification you are doing, the output should not change. Whatever you want to do it, but output should not affected. What is the output tell? When I take G and H, what is the output tell? If I take only G and H, what is the output? For example, here G and here H. What is the output tell? Output you tell G by 1 plus GH. If you add one positive feedback, here plus, opposite sign means minus. Numerator term is what? Opposite sign means minus. Numerator term is what? G. One more negative feedback, if you add it, what happen? Opposite sign means plus. Numerator term as it is means G. G cancel. What you are getting? G by 1 plus GH. That means the output is not going to be changed. By adding one positive and one negative feedback, the output does not changes. The output does not changes. The output does not changes. So that's why we are adding one positive and one negative feedback. Now I'll simplify up to positive feedback. If simplify up to positive feedback, what I will get here? Come on, R of S. Here plus summing point. Now come on, simplify. First G of S divided by up to this positive feedback, you have to simplify. G of S, first H simplify. 1 plus G of S, H of S. Then opposite sign of the feedback. Plus means minus. Here plus is there, so minus. Numerator term as it is in the denominator, so G of S. Numerator as it is in the denominator means G, minus G of S. Plus means minus. Numerator term minus G of S. Now here C of S. What is left to tell? negative feedback minus negative feedback left, negative feedback left. Then here E of S. This is the error. Here E of S. This is the error. Error. So now this function, whatever we got it, that is called GE of S. G of S is called equivalent open loop transfer function of a non-unity feedback system. Non-unity feedback system. That means what is G of S? G of S equal to G of S by 1 plus G of S H of S minus G of S. G of S equal to G of S by 1 plus G of S H of S minus G of S. And H of S is what? 1. And H of S is 1. H of S equal to 1. To get the type of non-unity feedback system required G of S only. To get the type of non-unity feedback system, type of non-unity feedback system, to get the type of non-unity feedback system required G of S only. Required G of S only. When you want to get the type of non-unity feedback system, we required G of S only. GE of S only. Okay, na? Okay, na? Right. Next, we'll solve one problem. Okay. Want to break or continue? Most of them are asking break. Take the break. After the break, I'll continue. 10 minutes break you take. After the break, I'll continue. Okay. You take 10 minutes break. Next, you have to solve the problems. We'll solve it. Take the 10 minutes break. Okay. Next. Okay. Right. Not a problem. Right. Not a problem. Find the steady state error. Find the steady state error to the non-unity feedback system. To the non-unity feedback system. To the unit step input. To the unit step input. Draw the diagram. Come on, do it. Convert into unity feedback. Convert into unity feedback. Convert into unity feedback. Come on, do it. So what happened? Add one positive feedback, add one negative feedback. Yes. Add one positive, one negative feedback. Now simplify all the blocks up to positive feedback. Come on. Find it. Come on. So what I'll get? R of S. Or directly you solve it. Why to draw the block diagram? You'll write GE of S. So what I'll get? 100 by S into S plus 10. Opposite sign of the feedback. Minus means plus. Numerator 100. Product with feedback gain 1 by S plus 5. Opposite sign of the feedback. Here plus means here minus. Numerator term 100 into feedback gain 1. Yes or no? Opposite sign of the feedback plus numerator 100 into feedback gain 1 by S plus 5. Again plus opposite sign means minus. Numerator term 100, feedback gain 1. So now simplify this. G of S equal to 100 into S plus 5 divided by S into S plus 10 into S plus 5 plus 100 minus 100 into S plus 5. Right. Next, come on. Simplify this. 100 into S plus 5 divided by S cube plus 15S square plus 50S plus 100 minus 100S minus 500. Now solve this. So G of S equal to 100 into S plus 5 by, so S cube plus 15S square. Here minus 50S, or plus 50 minus 100 means minus 50S. Minus 400. H of S equal to 1. H of S equal to 1. Now what is the type of the system? What is the type here? Type 0. No pole at origin, na? Can you take S term common? No. So that means type 0 system. Type 0 system. So which input we want? Steady state error, step input. Step input also 0. So ESS equal to A by 1 plus K. A is unit step 1. So 1 plus K. K is called numerator constant 500 divided by denominator constant minus 400. So now solve it. 2 zeros are cancelled. What is the answer? Minus 4. Steady state error equal to minus 4. So minus 4 is the answer. So this is the answer. Like this, you have to calculate steady state error to the non-unity feedback system. See, any question they ask, the type of the non-unity feedback system, compulsory you have to convert into unity. Compulsory you have to convert into unity. Type defined for only unity feedback systems. Okay, na? Convert into unity. That's all. Okay. But there is another simple method, shortcut method. So listen. If block diagram or signal flow graph or closed loop transfer function or non-unity feedback system is given. Non-unity feedback system is given. Then, so if non-unity feedback system is given, then steady state error equal to, one more formula is there for steady state error, that is limit t tends to infinity E of t, that equal to limit t tends to infinity, sorry, R of t minus E of t. Apply Laplace transform and get the answer. Final value theorem. So ESS equal to limit S tends to 0, S into R of S minus E of S. Limit S tends to 0, S into R of S minus C of S. R of S minus C of S. Now tell. So take R of S common. So ESS equal to limit S tends to 0, S into R of S, take it common. Then what I will get? 1 minus C of S by R of S. This C of S by R of S is called closed loop transfer function. They simply use this formula, no need to convert into unity and all. This is a simple shortcut. S into R of S into 1 minus closed loop transfer function. But this is valid for only single input, single output system. Valid for only single input, single output system. Not for multi input, multi output, single input and single output system. Because for multiple input, multiple output, we don't get transfer function first of all. We'll write only output. So it is valid for all the problems, all the problems, even for unity feedback also valid. But better for unity feedback, always use the word type and then get the answer. Type and input, compare and get the answer. In case given any block diagram, signal flow graph or closed loop, why? Because if you give some block diagram, actually, how to find steady state error means sometimes they'll give a little bit big block diagram. How to find means that block diagram should be left with unity feedback. That block diagram should be left with unity feedback. Remain all the block gain should be taken as GE of S. For example, see here, if you given this 100 by S into S plus 10, 1 by S plus 5, this block diagram given. If you want to find steady state error, it should be left with unity feedback. Means I need to add positive feedback and left with unity feedback and remain all the blocks should be taken as G of S. Instead of all, what I am telling, directly find a closed loop transfer function, use this formula, directly will get the answer. For example, see here, same problem I'll take R of S plus, what is the block gain here? 100 by S into S plus 10. C of S bar. Here minus. So 1 by S plus 5. That's all. Now find closed loop transfer function. Substitute here, you will get the answer. Find closed loop transfer function. C of S bar of S 5. That equal to what? 100 by S into S plus 10. Opposite sign of the feedback plus numerator 100. Opposite sign of the feedback plus numerator 100. Product with feedback gain 1 by S plus 5. Then get the answer. What is the closed loop transfer function? C of S bar of S equal to 100 into S plus 5 divided by S into S plus 5 into S plus 10 plus 100. So this is the closed loop. That is 100 into S plus 5 by S cube plus 15S square plus 50S plus 100. That's all. Now use this, substitute here, get the answer. Same answer you will get. Substitute here. So ESS equal to limit S tends to 0, S into R of S. Unit step input now 1 by S into 1 minus closed loop transfer function 100 into S plus 5 by S cube plus 15S square plus 50S plus 100. SS cancel. S tends to 0, substitute 0, 0, 0. That means what you are getting 1 by 100 into 5 by 100. 1 minus 4, 5 means minus 4. Same answer you will get. Same steady state error you will get. So whenever they give block diagram, It is a closed loop transfer function, stable only. It is 100% stable. You should check the stability of closed loop system, not G of S stability. Not G of S stability. Steady state errors are valid for only closed loop system stability. You have to check the closed loop system stability, not for the G of S. You should not check for this. You have to check the closed loop stability. Okay. So this is the what steady state. This is the second method, simple shortcut. It is a method 2. Simple shortcut. So anywhere, if you are unable to convert into unity feedback, just find closed loop transfer function, use this formula, you'll get the answer. Okay. Next. Okay, na? Last, one more problem. Next problem. Find the K value. Find the K value. To get the, actually here, sometimes they are asking a wrong questions in the exam. Question itself wrong they are asking. The question itself wrong they are asking. So, how to solve it? Listen. Find the K value. Question itself wrong they are asking. Find the K value to get the steady state error of given system they'll give. Find the K value to get the steady state error of 10. Steady state error of 10 to the given system. To the given system. To the given system. G of S, H of S equal to. They'll give like this, K by S into S plus 1 into S plus 2. To the unit ramp input. To the unit ramp input. To the unit ramp input. Unit ramp input. They'll give like this. Actually, when given GH, we cannot find first closed loop transfer function. Steady state errors are valid for only unity feedback. H of S should be 1, but they given GH. What is G? What is H also? We don't know. We don't know what is G. We don't know what is H. And we cannot find closed loop transfer function also. Not possible to find closed loop transfer function. What is the closed loop transfer function? G by 1 plus GH. What is G here? We don't know. It is not possible to find closed loop transfer function. So like this question given, actually question is wrong, but in the option question wrong, it won't be there. Nah? That is the problem. Then what you have to do? Just assume unity feedback and proceed. Just assume unity feedback and proceed. That's all. Assume unity feedback. Question is wrong. So assume unity feedback and solve. That's all. So what do you want? What is the steady state error for unit ramp? A by K. What is error given? 10. So A is 1. What is K? K by 2. Numerator constant by denominator constant. Numerator constant by denominator. K by 2. That means 10 equal to 2 by K. K equal to what? 2 by 10. That means 0.2. K equal to 0.2. That's all. K equal to 0.2. That is the answer. So last problem. Last problem. Find the minimum possible steady state error. Minimum possible steady state error. Minimum possible steady state error. Find the minimum possible steady state error to the given unity feedback system. To the given unity feedback system. To the given unity feedback system. to the unit ramp input. To the unit ramp input. Draw it, command do to the given unity feedback system. That is G of S equal to K by S into S plus 1 into S plus 2. Command do it. What is the minimum steady state error possible to this system? Tell the answer, anybody. Tell the answer. Come on, do it. Point 33. Very good. Listen. Listen. How to find minimum possible steady state error? First of all, minimum possible steady state error means you have to take the largest value of K for which system stable. K very, very large, steady state error becomes 0. For example, what is the steady state error for RAM? A by K. If I take K infinity, error becomes 0. But I cannot take K infinity. K infinity means closed loop system become unstable. So that means minimum how it is possible? You have to take a largest value of K, largest K for which system stable. K should be large. K should be large for which system stable. K should be large for which closed loop system stable. For which closed loop system stable. K should be large for which closed loop system stable. That is called K marginal value. That is called K marginal value. That means K value for marginal stability. How to find means RH criteria. It will come. Next topic is RH criteria only. Next chapter it will come. So first write characteristic equation. So 1 plus G of S equal to 0. 1 plus G of S equal to 0. What is the characteristic equation? Tell. Simply 1 plus K by S into S plus 1 into S plus 2 equal to 0. Now expand this. Expand this. S cube plus 3S square plus 2S plus K equal to 0. S cube plus 3S square plus 2S plus K equal to 0. So this is the what? Characteristic equation. Now what is the K value? Simple shortcut I will tell. Product internal term 6. External terms K. So that means K marginal. Largest value of K for stability is 6. Largest value of K is 6. How it is means it will come in the RH criteria. I will discuss. How we are finding means that I will discuss. Just internal product equal to external product in a third order system. The system will become marginal stable. That means that is the largest value of K. Actually 6 should not consider. For 6 is marginal stable. Less than 6 you have to consider. Less than 6 means how much? 5.999 and again approximately 6 only. That's why I can take it 6. Then what happen? I can write G of S equal to 6 by S into S plus 1 into S plus 2. So H of S equal to 1. H of S equal to 1. Now find steady state error. Minimum possible steady state error you will get. So ESS equal to A by K. So A is 1. K is 6 by 2. That means 1 by 3. That equal to 0.33. 0.33. So minimum possible steady state error is 0.33. Minimum possible steady state error. Minimum possible steady state error is 0.33. That's all. This is the answer. So with this, the chapter end. If you have any doubt, you can ask in this chapter. Okay, no doubts. After the class, I'll discuss. Okay. Next, we'll start the stability. So by tomorrow, all of you try to solve all the questions in the chapter 3. Volume 1 at least. Chapter 3, volume 1, you try to solve it. So in this chapter, compulsory 2 marks bit will be there in the gate. IES అయితే 3-4 questions will come. So minimum 1 question compulsory. So solve all the questions in volume 1. Next, go for stability. Put the heading stability. Jivika. Jivika. Tiwari. Tiwari.
Hello.
Tell.
Hello, good evening, sir.
Good
Sir,
evening, tell, jaldi.
sir, I want to ask what is volume 1 and volume 2? It is a bit and byte volume.
Books they given na, volume 1, volume 2, 2 books are there na.
Sir, actually I get bit and byte. Nothing like a volume 1 and volume 2. So bit and byte is called volume 1 and volume 2.
In the book cover page, they will write volume 1.
Sir, can you show me?
Or otherwise, simply control system booklet is there.
Yes, sir, control system.
That is volume
theory
1
book.
only.
Sir, control system theory book. Control system theory book we have. And we
that
have
only
one
volume 1.
And what is a volume 2?
Volume 2 practice questions.
Okay, workbook.
Blue book.
Okay, sir.
Right. Next, stability. I'll discuss the doubts after the class. Stability. Stability. When we can say system is stable? When we can say system is stable? When we can say system is stable? If you take any linear time invariant system, you take any LTI system. You take any LTI system, if you give bounded input, the output must be bounded. If you give bounded input, the output must be bounded. Bounded input, the output must be bounded. If input to the system is 0, the output must be 0, irrespective of all the initial conditions. If input to the system is 0, the output must be equal to 0, irrespective of all the initial conditions. Then we can say that the system is stable. So that means, what is the statement? A linear time invariant system. A linear time invariant system. A linear time invariant system is said to be stable. Is said to be stable. Is said to be stable. Is said to be stable if satisfies following condition. If satisfies following conditions. Satisfies following conditions. First one, if the system is excited by bounded input, if the system is excited by the bounded input, the system is excited by the bounded input, the output must be bounded. 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 If the input to the system is 0, if the input to the system is 0, input to the system is 0, then the output must be 0. Then the output must be 0. The output must be 0. So if both are satisfied, then I can say that the given system is stable. If both are satisfied, then I can say that the system is stable. But the stabilities are classified into two ways. The stabilities are classified into two ways. Classified into two ways. Based on operating condition. Based on operating condition. Operating condition. That's one. First one is absolutely stable system. Absolutely stable system. Absolutely stable system. Second one is conditional stable system. Conditional stable system. Conditional stable system. Second one is conditional stable system. First one is absolutely stable system. So first, absolutely stable system. First one, absolutely stable system. Absolutely stable system. Stable system. So absolutely stable system means what? Here the system is stable for all the values of system parameters. Here the system is stable. The system is stable. The system is stable for all the values of system parameters. System parameters. For all the values of system parameters. So here the system is stable for all the values of system parameters like K, like A. So what are the system parameters? K and tau. For K, all K like 0 to infinity, like K from 0 to infinity, K from 0 to infinity. For all the values it is stable. Then we can say it is absolutely stable system. Second one, conditional stable system. Conditional stable system means for certain range of system only stable. Conditional stable system. Conditional stable system means here the system is stable. Here the system is stable. The system is stable for certain range of system parameters. For certain range of system parameters. Certain range of system parameters. System parameters. Certain range of system parameters. Like K from 0 to 100. Like K from 0 to 100. Like K from 0 to 100. Okay. So this is the conditional stable system. Next, marginal stability. Marginal stability. What is the marginal stability? Marginal stability. Marginal or critical. Critical stable different. Critical damped is different. When given any question, you should be very much careful. They mentioned critical damped or critical stable. Critical stable means marginal stable. marginally, critically, limitedly stable means marginal stable, limitedly, just unstable, all are same words. Just unstable system. Just unstable system. All are same. So be careful. Be careful. Don't confuse either word given critical stable or critical damped. Critical damped means zeta 1. Once in IAS, for 1 mark bit asked, that fellow given like this. Characteristic equation given s square plus I think ks plus something, for example 25 equal to 0 given. They asked the k value for critically stable. K value for critical stable they asked. K for critical stable. K for critical stable. What they did, some people, critical stable means they consider critical damped. Gone jindagi. Critical damped consider. Critical damped means zeta 1. Zeta 1. Very easy question. Omega n become 5. So 2 zeta omega n equal to k. So 2 zeta 1 omega n 5, then k 10 they written. Option 10 will be there. Selected. Gone. It is wrong. Critical stable means marginal stable. Marginal stable means undamped system. Zeta 0. Zeta 0 means k 0. Answer is 0. So be careful whenever they ask the question critically stable and critical damped. Read the question very carefully. Is it critically stable or is it critical damped? Be careful. Okay? Be careful. Is it critically stable or critical damped? So critical stable means it is a marginal stable system. Okay, na? Be careful. Next. So what is the definition tell? A linear time invariant system. A linear LTI put it. Linear time invariant system is said to be marginal stable. Is said to be marginal stable. Marginal stable if for the bounded input. If for the bounded input. Bounded input. The output maintains. The output maintains. The output maintains constant amplitude. Constant amplitude. Constant amplitude and frequency of oscillations. And frequency of oscillations. Frequency of oscillations. The output maintained constant amplitude and frequency of oscillation. Linear time invariant system is said to be marginal stable if for bounded input the output maintains constant amplitude and frequency of oscillations. Then the system is marginal stable. Then the system is marginal stable. Already I told na, marginal stable. The linear time invariant system is marginal. Okay, na? So when you will get this condition, the non-repeated poles on imaginary axis. The non-repeated poles. The non-repeated poles on j omega axis. On j omega axis gives the non-repeated poles on j omega axis gives the response of response of non-response of constant amplitude and frequency of oscillations. Constant amplitude and frequency of oscillations. Frequency of oscillations. The non-repeated poles on j omega axis gives the response of constant amplitude and frequency of oscillation. The system becomes marginal stable. The system becomes marginal stable. So be remember. Okay. Next. Karthik, What is the doubt? Karthik. Mallesh. Mallesh. Okay, right. Next. Next. Relative stability. Next, relative stability. Relative stability. Relative stability. It is approximate only, not exact actually. Exact relative stability want, you have to go for frequency domain. So approximate. Even you can go for our root locus also, one way it gives exact relative stability. Root locus also gives exact relative stability. But not RH criteria. But not RH criteria. RH criteria gives the approximate relative stability only. RH criteria gives the approximate relative stability only, but not exact relative stability. What is the relative stability? First of all, this relative stability concept valid for only closed loop stable systems. Relative stability concept, relative stability is applicable for only closed loop stable systems. Only closed loop stable system. It don't apply for unstable system. Closed loop stable systems. We don't apply this relative stability concept for unstable system. Why? Because listen. So for example, listen by all of you. So this is the S-plane. This is the S-plane. Here it is 0. S equal to 0 here. S equal to 0. J omega axis. Now relative stability is with respect to certain point in the left hand side. Relative stability is with respect to certain point in the left hand side. How they'll ask, for example, check the relative stability about S equal to -1. That means you have to check the poles with respect to S equal to -1. Either poles are left of S equal to -1 or not, you have to check. You have to check that either poles are left of S equal to -1 or not, we have to check it. Left of S equal to -1 or not, we have to check. That means what happened? In case system is unstable, that means already poles are there in the right side. In case system unstable, poles are there in the right side. But you are checking in the left. That's why if you are checking in the left, it is just like foolishness only. Already system unstable, poles are there in the right side, but you are checking is there all are in the left or not. So that's why before solving the question which belongs to relative stability, first you have to check the stability of the system. If all the poles lies in the left of S-plane, all the poles lies in the left of the S-plane, that means the system is stable. If all the poles lies in the left of S-plane, that means the system is stable. Then how leftmost the poles are there, we have to verify. How leftmost the poles are there, we have to check it. We need to check how leftmost it is there. So for that, what you have to do, that means basically this concept valid for only closed loop stable systems. If it is left side is there, how leftmost is there, that we have to verify. For that, what you have to do, we need to shift. For example, I want relative stability about -1. I want to check the leftmost of S equal to -1. For that, first what you have to do, you have to shift the axis to the location of S equal to -1. We have to shift the imaginary axis. We have to shift this axis. You have to shift the axis location. Shift axis location. Shift axis location. Shift axis location. We have to shift the axis location. So we have to shift the axis location. So after shifting axis, So shift to the s equal to -1 or minus sigma. General notation I'll take. S equal to minus sigma. I want to relate to stability about S equal to minus sigma. We'll shift to S equal to minus sigma. After shifting, we have to consider it is a new plane that is called jet plane. After shifting, you have to consider it is a new plane. It is called jet plane. Here z equal to 0. With respect to z equal to 0, we have to check the poles. In case poles lies left of z equal to 0, system is relatively stable. In case poles lies left of z equal to 0, system is relatively stable. Right of z equal to 0, then system is relatively unstable. Right of z equal to 0, system is relatively unstable. Exactly on the line of z equal to 0, relatively marginal stable. Exactly at the location of z equal to 0, system is marginal stable, relatively marginal stable. So like this you have to check. So, but what is the advantage of shifting and doing? Tell. We'll shift s equal to minus sigma, z equal to 0. We'll check the relative stability. But what is the advantage? What is the advantage of doing all these things? The main objective of relative stability is to find the system time constant by using. So, for example, to find the what? System time constant, to check the system time constant, either less than, greater than, or equal to certain value, you want to check it, you have to go for relative stability concept. So, for example, on this line, what is the time constant? Tell. So, this is minus sigma. Now, what is the time constant? -1 by minus sigma. That means 1 by sigma. So, time constant is 1 by sigma seconds. If you're relatively stable, what happened? As the poles moves left, what happened? Time constant decrease. That means relatively stable, the time constant becomes less than 1 by sigma. The tau become less than 1 by sigma. Relatively unstable, the time constant greater than 1 by sigma. Relatively unstable, the time constant greater than 1 by sigma. Relatively stable, time constant less than 1 by sigma. Relatively marginal stable, time constant equal to 1 by sigma. That means by using relative stability concept, we can find system time constant and system time constant, settling time, and time required to reach steady state by using relative stability concept. By using, I'll write here. By using relative stability concept, by using RS means relative stability concept, we can find system time constant, system time constant, settling time, and time required to reach steady state. Time required to reach steady state. Time required to reach steady state. So these things we can find. Even not only that, shift axis location equal to -1 by tau. Shift axis location equal to -1 by tau. -1 by tau. Sometimes they will give like this. Check either time constant greater, lesser, or equal to 1 second. That means what you have to do? You have to substitute here tau equal to 1. If I substitute tau equal to 1, the axis shifted to -1. The axis shifted to what? Substitute tau equal to 1. Shift axis location is -1. So shift axis location equal to -1. So, and one more thing here, whenever you see a question which belongs to relative stability, forget all these things. Just what you don't draw this diagram and all. Be remember simply, they'll give characteristic equation in terms of S. That S replaced by S, you should replace in terms of Z. S should be replaced in terms of the Z. So S replaced by S equal to Z plus axis shift location. Z plus axis shift location. Z plus axis shift to location. Z plus axis shift location. Just S equal to Z plus. For example, axis shifted to -1. S equal to Z -1, you shift it. That's all. In case they'll give time constant, S equal to Z minus 1 by tau. Check whether time constant greater, lesser, like this, they'll give S equal to Z minus 1 by tau. S equal to Z minus 1 by tau. 1 by tau. Z minus 1 by tau. S equal to Z minus 1 by tau. If relatively stable, then I can say that time constant is less than given reference value. If relatively stable means time constant less. Relatively marginal stable means time constant equal to given reference value. Relatively unstable means time constant greater than given reference value. Time constant greater than given reference value. That's all. So this is about the relative stability. This is about the relative stability. Next, we'll start RH criteria, Routh-Hurwitz criteria. Simply today, we'll discuss the small basics. Tomorrow, we'll solve the problems. Okay? RH criteria, Routh-Hurwitz criteria. It is also very, very important. Routh-Hurwitz criteria, RH criteria, or RH criterion, whatever it is. What we can find in RH criteria? What is the main objective, purpose? Purpose to find the closed loop system stability. To find the closed loop system. In case you are unable to find open loop system stability, then we can take characteristic equation, we can apply RH criteria, we can find open loop stability. We can find open loop stability. If you are unable to identify open loop stability directly, we can apply RH criteria, we can find open loop stability also. But open loop stability we can identify directly because they'll give in a pole zero form. Closed loop expanded form. That's why to find closed loop system stability. First purpose to find closed loop system stability. Second one, to find number of poles. To find the number of poles in the left, in the right, comma, left, comma, to find the number of poles in the right, comma, left or on imaginary axis, on j omega axis of the S plane. Left, right, and on j omega axis of the S plane. J omega axis of the S plane. Third, actually main objective of RH criteria is to find the number of poles in the right eye. Main objective is to find the number of poles in the right hand side. Number of poles in the right hand side. Next, third, to find range of K value for system stability. To find range of K value. Range of K value for system stability, closed loop system stability. Closed loop system stability. Next, fourth one. To find K value. To find K value to become the system marginal stable. To become the system. To become the system is marginal stable or undamped system. All marginal stable systems are undamped systems only. Undamped system. Next, fifth one. To find the natural frequency of oscillation. To find the natural frequency of oscillation. Or undamped oscillations. That is what omega n. Next, to find the relative stability. To find the relative stability. By using relative stability concept, we can find system time constant, settling time, time required to reach steady state, TSS. So all these factors we can find by using the RH criteria. All these 6 factors we can find by using RH criteria. Okay. Next. See, to find the closed loop system stability, actually there are 4 techniques are there. Listen, all of you listen. Listen, it is very important. Relative stability, RH criteria itself not started. Relative stability questions will solve in the RH criteria. Relative stability questions will come in RH criteria. Okay. That is just idea sake only. Just idea given. Problems will solve in the RH criteria. Right. Next. See, we are having to find closed loop stability. Want to find closed loop stability. Total how many techniques are there? 4 techniques are there. So what are that? RH criteria. Next, root locus. Next, Bode plots. Next, Nyquist plots. Polar also included in the Nyquist only. Nyquist plots. So there are 4 techniques are there. All these 4 techniques are to find closed loop system stability only. But when you are using RH criteria, with RH criteria, if you want to find closed loop stability, we required characteristic equation. So by using RH criteria, if you want to find closed loop stability, required characteristic equation. Required characteristic equation. Required characteristic equation, that is 1 plus G of S H of S equal to 0. So if you want to find closed loop stability by using RH criteria, required characteristic equation 1 plus GH equal to 0. Whereas in remain all the stability techniques, whereas in remain all the stability techniques required open loop transfer function of unity or non-unity feedback system. Here required open loop transfer function of a unity or non-unity feedback system. Non-unity feedback system. That is G of S, required G of S, H of S may be equal to 1. Or G of S, H of S. H of S may be 1 or may not be 1. So, if we want to find closed loop stability, where in RH criteria, characteristic equation required. Whereas in root locus, Bodo plots, Nyquist plots, so required G of S, H of S. G of S, H of S. H of S may be 1 or may not be 1. So why not here also characteristic equation? Means it is very difficult to draw a diagram by using characteristic equation. I'll explain. In the starting of the root locus, I'll explain why we are unable to draw a diagram by using characteristic equation. Why we cannot draw a Bodo plot or root locus or Nyquist plot by using characteristic equation. That I'll discuss in the root locus. Okay. It is not possible to draw a diagram by using the what? Characteristic equation. Okay. Next. I am already coming to end. So next another 5 minutes, I'll try to close. So here be remember to find the closed loop stability, to find the closed loop stability by using RH criteria, required characteristic equation, that is 1 plus GH equal to 0. In remain all the stability techniques, in remain all the stability techniques, required open loop transfer function, that is G of S, H of S. Or completely want to write open loop transfer function of a unity or non-unity feedback system. Non-unity feedback system. That is G of S, H of S. So be remember this, okay? Okay, still next some more is there. Okay, tomorrow I'll discuss. Time already over. So characteristic equation, necessary, sufficient. Next tomorrow I'll discuss necessary and sufficient conditions, and then we'll solve the problems. Okay? If you have any doubt, you can ask. You can write the hand if you have any doubt. No doubts? If you have any doubt, you can ask. Arsha. 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 No doubt? Hello? Hello? No. Meena? Meena?
Hello, sir.
Tell.
Sir, open loop transfer function is only GS, na sir?
That is just open loop transfer function. That is for open loop system. Closed loop system means G of S, H of S. In the first class I discussed na.
Sir, that is open loop gain. GS, G of S into H of S is.
Loop gain or open loop transfer function of unity feedback, open loop transfer function of non-unity feedback, all are same. Yeah.
Sir,
First
G
class
of S.
PDF is there once you refer it.
Okay, sir.
All are same.
Okay, sir. Thank you.
Next, Arsha. Next, Naveen.
Sir, in page number 9F,
Ah.
sir, So in that you written one formula, sir.
Which formula?
Sir, here 0.8 equal to K A into K by 1 plus K.
Hmm.
So from where you got that formula, sir?
What is K? K is a gain of the system, na?
Yes, sir.
This is AK, na?
AK, sir.
K is called closed loop gain here because it is closed loop system. What is the closed loop gain? Tell.
K
Put
by
S0, closed loop gain
K
you will
by
get
1 plus K.
numerator
Yes, sir.
constant by denominator constant. What is the numerator constant? K. Denominator
K
constant
by 1 plus K.
That's
Okay.
all.
Sir,
Okay.
and again, sir, you told no, sir, marginal or critical or limitedly unstable system, and you again telling that marginal stable system. How like, sir?
All are same words, Ayavi.
కాదు సార్, మీరు అన్స్టేబుల్ సిస్టమ్ అని కూడా మెన్షన్ చేశారు మళ్ళీ
Just
మార్జినల్
unstable, not unstable. Just unstable.
ఓకే సార్.
Just unstable అంటే marginal stable.
ఓకే.
Just unstable means marginal stable, not unstable. There is lot of difference is there. Unstable, just unstable.
ఓకే సార్.
Next, Naveen. Naveen.
సార్ కంప్లీటెడ్ సార్.
Okay, amma. Next, Karthik.
Hello, sir.
Tell.
Sir, in the stability, second point you have mentioned in the stability,
Voice not
can you
clear.
explain it
Check
one
it
more time?
once connection. Tell.
Hello,
Tell.
is it audible?
Tell, man. Tell.
The second point of stability. Sir, can you explain it once again? If input
Which
of
one?
the
Which
system,
one? Which
input
one?
to the system is 0, then
Input is
if the
0.
input to the
If there is
system is
no
0,
input gives. There is no input gives. The output should
Okay.
be bounded, just like impulse.
okay,
Okay, na?
yes, sir,
Okay.
yes, sir.
Okay. Next. Susmita.
సార్ గుడ్ ఈవినింగ్ సార్.
Good evening. చెప్పమ్మా.
సార్ ఇక్కడ స్టడీ స్టేట్ ఎర్రర్స్ ఒక్కోసారి కనుక్కోవాలంటే కొంచెం కన్ఫ్యూజన్ గా ఉంది సార్.
Type
ఇప్పుడు
compare చేయి. Compare the type. That's all. Type and input compare.
ఇప్పుడు యూనిటీ ఫీడ్బ్యాక్ అయితే డైరెక్ట్ గా టైప్ అండ్ ఇన్పుట్ కంపేర్ చేసుకుంటాను సార్.
అవును.
ఒకవేళ నాన్ యూనిటీ ఇంక ఏ క్వశ్చన్ ఇచ్చినా కానీ
I given one formula na. Find the closed loop transfer function and substitute. That's all. Directly you'll get the answer.
S into RFS into 1 minus
1 minus closed loop transfer function use. That's all. You will get the answer directly.
ఓకే, ఇంకా దేనికైనా ఆ ఫార్ములా యూస్ చేస్తాం.
Use
యూనిటీకి
that
ఒకటే,
formula. Automatically you'll get the answer. No doubt.
మిగతా వాటికైతే టైప్ ఇన్పుట్ కంపేర్ చేసి సరిపోతుంది
అంతే.
కదా సార్ అది.
That's all. That's all.
ఓకే, అదే సార్
Okay.
ఒకసారి రాంగ్ ఆన్సర్స్ వస్తున్నాయి, అది ఆ ఫార్ములా కొంచెం.
No. You don't get wrong answer. You'll get the calculation mistakes. You'll do. That's all.
ఓకే సార్.
Okay, ma.
థ్యాంక్ యూ సార్.
Next, anybody? Arsha. Arsha.
Hello,
Tell man.
sir. I had doubt in volume 2 booklet, sir. One problem.
Which chapter?
Chapter 3, sir.
Chapter 3. Tomorrow we'll discuss.
Okay, sir.
Next. Next, Venkatesh.
Sir,
Tell.
in the topic steady state error due to disturbances, sir, how you find the E of S by R of S equal to 1 by 1 plus G1?
Signal flow graphs. Signal flow graph. What is the forward path gain from R of S to E of S?
1, sir.
1 by loop gain. What is the loop gain?
G1, G2.
1. Opposite sign of loop gain na?
Yes, sir.
Minus G2 and plus G1, G2. That's all.
Okay, sir. For
Similarly,
D
E
of
of S by D of S you find minus G2 by 1 plus G1, G2.
minus G2 by 1 plus.
This
Okay,
is E by
sir.
R.
Yes,
Now
sir.
find E by D. What is the path gain from D to E? G2 into minus 1 na, here na output.
Yes, sir.
What is the path gain? G2 into -1 means minus G2.
Minus G2.
Divided by loop gain same 1 plus G1 G2.
Okay, sir.
That's all. Okay, na?
Okay, sir.
Okay. Any more? Any more doubts?